So last but certainly not least is Professor Ajit Sarmah. Professor Sarmah is a researcher in civil environmental engineering, and his focus is on green technologies to reduce the carbon footprint in the construction sector and sustainable remediation. Thank you, Ajit.
Thank you very much, Frank. Good evening, everyone. Hope you guys are having a good time. And thank you for being here. And I would like to just briefly acknowledge for the invitation to speak here. So if I just put this slide, you already know what I'm going to talk about, right? Climate change, global warming, climate change, global warming. Everybody's talking about that. This is the big challenge that the world faces right now. But what about if I could have a particular material that could actually solve this problem? Could a special type of carbon actually help these carbon problems? And I've got here a special type of charcoal. And this charcoal is not your average humble charcoal that you would make every time you burn a piece of wood at the back here. This particular charcoal has gone through a process which we have known about since ancient times, which we turn into today, and we call it biochar. So what is biochar? Biochar is basically a charcoal that you can prepare if you heat in the absence of oxygen or under limited amount of oxygen in a process called pyrolysis, which is an age-old technology. And in the process of pyrolysis, what happens? The volatiles escape, all the gases are partially driven off, and what you get is a solid residue that's called biochar. And this particular biochar that I'm holding here, this has been prepared from something you wouldn't expect, and that's from poultry litter, chicken poo. Now the carbon that I have here in this charcoal is about 60 to 70% of pure carbon, and that is highly stable. Evidence suggests that this charcoal, if you put it onto the soil, it would stay there for hundreds and thousands of years. I don't know if you can see this image here. This is from the Amazon River that you can see here. So we have known about biochar since last 2,500 years. Amazonian Indians, they used to call it terra preta de Indio, or terra preta simply in Portuguese. That means black earth or dark soils. And they know it enriches soils. Now, if you take a close look at biochar under a microscope, that's what you see. It's an image, scanning electron micrograph image of biochar. It is chock full of passageways. All those pores that you see, some are big, some are small, some have been extremely smaller. All these pores basically retain nutrients and conserve water. And microbes, they just simply love it. This is the habitat for microbes. But again, this is not food for microbes. So when you have so many pores, so many passageways, open areas, rather than more solids, you think that it will have high surface area. Indeed, 1 gram of biochar would have at least 400 square meter surface area, which is roughly like a basketball court, maybe 28 meters by 15 meters. You can basically fold it into a small sugar cube, maybe slightly smaller than that. Isn't that amazing? Now, as it turns out, this particular technology is the only carbon negative technology that we have right now. It reduces carbon dioxide in the atmosphere by taking carbon neutral process of decomposing organic matter and turns into carbon negative. Well, back to carbon problem. I mean, of course, you know what I'm going to talk about, but just simply looking at this image. Nearly 40% of energy associated with construction and building sectors comes this way, carbon dioxide emission. Now, to make cement, that accounts for nearly 36% of the carbon dioxide emissions. And in total, 8% of the anthropogenic carbon dioxide emissions. Now, cement is like a glue. It basically holds concrete together. What do you need? Sand, cement, and water, and you throw in some aggregates or gravels, and you have your concrete. Concrete is the most widely used man-made material after water. A lot of people, they don't realize it. Water is the most consumed resource globally, right? So, to make cement, you have to pay a price for that. Cement has got a huge carbon footprint. To do any construction, you need concrete, okay? And 8% of the global carbon dioxide emission comes from cement industry. Just to give you an analogy or put things into perspective, if cement was a country, it would be the third largest emitter in the world after China and United States. That's how it is. So, if we have a material produced from waste biomass, which would otherwise land up in landfill and create all sorts of emission issues, there's a good thing, right? You have two scenarios here. It's a win-win scenarios because you can use this particular carbon that is present here, unique in qualities, high surface area. It has got also other different qualities. And you can use it as a replacement for synthetic cement, as well as for sand. And you can get similar sort of strength and durability for like conventional concrete. That's a win-win scenario for us. Because what you're doing is, you're not only sequestering the carbon back in the concrete, but you're also reducing the emissions. Our research has shown that if you replace concrete with biochar, there's a significant reduction in net carbon dioxide emissions. 20% reduction in net carbon dioxide emission when you replace some of the cement and sand with biochar. And that is an excellent message for us. Now, globally, if you look at the biochar technology, it could actually help us reduce greenhouse gas emissions by nearly 3.4 to 6.4 picogram carbon dioxide equivalent. That is roughly, or out of that, nearly 49 to 59% is attributed to the carbon dioxide withdrawal from the atmosphere. And also our estimations suggest that if we produce biochar, this carbon material, whatever the biomass you're talking about, it depends again. Different types of biomass will have different types of biochar. But globally, if you look at this biochar technology, if you produce 375 million tons of biochar simply from agricultural waste, that would enable you to sequester nearly 500 million tons of carbon dioxide. That's amazing, isn't it? So, what's the state of play? What's happening? The biggest stumbling block right now is that industries, private companies, and government bodies, they are worried of the risk associated with biochar technology. In life, there is no risk, no gain. That's my motto. To be able to go one step forward, you need to be able to come back, right? You have to take risk. So my position is that we risk more by waiting for an ancient technology, simple carbon negative technology, which is with us. So therefore I feel biochar is the carbon to solve the carbon problem. And we need to get on with the job. Thank you.